use the quotient rule to find the derivative of a function in the form of f of x divided by g of x. So in this video, we're going to be talking about the quotient rule. So, what is the quotient rule, you might ask? Well, the quotient rule is used to differentiate a function which has division. So just like with multiplication, if we want to take the derivative of a function divided by another function, we cannot just take the derivative of each function separately. That does not work, so please don't do it. It's not like addition or subtraction. The actual formula for the quotient rule, if we wanted to take the derivative of f of x divided by g of x, would be the derivative of f of x times g of x minus f of x times the derivative of g of x all over g of x squared. And yes, I know, huge pain to memorize, but it's just one of those things you gotta do, and the more you use it, the more you will subconsciously commit it to memory. Another popular way to remember it is if instead of f of x divided by g of x, it is high over low, because f of x is the function on top, it is higher than g of x, and g of x is low because it's lower than f of x. Now, the formula for this particular notation is not going to directly match the one that's already on the screen, but it is equivalent because multiplication is commutative. So that formula would be low d high minus high d low over low squared. Or you could even say it as low d high minus high d low over low d low, and off to math we go. So it's basically saying low times the derivative of the high minus high times the derivative of the low over low squared. And now if either one of those rhymes work for you, great, go ahead and use it. If not, if you like the first form better, please go ahead and use that as well. Personally, I like to think of it as the derivative of the top divided by the bottom. So I like to have it d over dx times top over bottom, and that is equal to the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So again, whichever one of these works best for the way your brain works, please feel free to use whichever one you prefer. Now let's take a look at an example. So here we want to let h of x equal f of x divided by g of x. And we want to use the quotient rule to find h prime of negative 5 if f of negative 5 is 26, f prime of negative 5 is 20, g of negative 5 is negative 3, and g prime of negative 5 is negative 2. So just like with the example in the product rule in the previous video, we have all the pieces, we just don't have the instructions to put it together. So let's start out with our function and take the derivative from there. So we know that h of x is going to be f of x divided by g of x. And we know how to take the derivative of this based on the formula on the previous screen. So h prime of x is going to be, get ready, f prime of x times g of x minus f of x times g of x all over g of x squared. And now this is the quotient rule for the general derivative, but we're not looking for the general derivative, we're looking for the derivative when x is equal to negative 5. So next up we can substitute negative 5 in for x. That's going to give us f prime of negative 5 times g of negative 5 minus f of negative 5 times g prime of negative 5. And I'm looking at the previous step and I can see that my prime mark didn't quite get in there, so let's just come back up and let's put the derivative right there. Alright, this is going to be all over g of negative 5 squared. Alright, well then from here, we can substitute in, because we now have the instructions, we know how all the pieces will fit into the puzzle. And we know that f prime of negative 5 is 26. And we can see that g of negative 5 is negative 3. And that's going to be minus. Well, let's see, we have f. Oh, oops, let's back that up a little bit. Totally substituted in the wrong values here. So you need to be careful when you solve these problems, because one tiny mistake will ruin it for you. Because f prime of negative 5, there it is 20. And then g of negative 5, that was correct, at negative 3. And then minus, and now we have f of negative 5, which we know is 26. And then f prime of negative 5 is negative 2. And that is all over g of negative 5, which we can see is negative 3. So we'll get negative 3 squared. And then from here we can just evaluate this expression. So 20 times negative 3 is going to be negative 60. Minus 26 times negative 2 is negative 52. And that is all over negative 3 squared is 9. And then we can simplify that to be negative 8 over 9 as our derivative of the function at negative 5. All right, our next example worded a little bit differently. We can see here that we want to let v of x equal x squared plus 3x over 4 over x squared minus 1, and we're being asked to find the derivative dv over dx. All right, so first thing we have to do is we have to identify the top and the bottom. So I'm going to label this x squared plus 3x plus 4 as my top, because it is, again, on top. And on the bottom is x squared minus 1. So, if we start with our derivative, dv over dx is going to equal the derivative of the top times the bottom minus the top times the derivative of the bottom and that's going to be all over the bottom squared. Alright, so now we just need to figure out what all these pieces are. So we'll do a little bit of work here over on the side. So let's see, we know that the top, we already defined that as x squared plus 3x plus 4. Then we just need to take its derivative, which will be 2x plus 3. Then next we have the bottom, which we've already identified as x squared minus 1. Then we just need to take the derivative of the bottom, which is 2x. Alright, so now we have the instructions. We have all the pieces. Let's put together our puzzle. So let's see, the derivative of the top is going to be 2x plus 3 times the bottom, which is x squared minus 1, minus the original top, which is x squared plus 3x plus 4, times the derivative of the bottom, and I keep forgetting to put that tick mark there, 2x, and that is all over the bottom, which is x squared minus 1 squared. Alright, so now this is technically the right answer, but remember Newton wants us to simplify this down, so it's time to put on our distribution pants and get to work. So we'll FOIL the first two terms together, and then we'll distribute the 2x into the last three terms. Alright, so what's that going to give us? Well, let's find out. That's going to give us 2x cubed minus 2x plus 3x squared minus 3 minus 2x cubed plus 2x cubed plus 6x squared plus 8x. And that's all going to be over x squared minus 1 squared. Now, we're going to leave the denominator as x squared minus 1 squared, since it's already in factored form, and eventually we might be able to cancel something out in the numerator. Alright, so let's see, we can continue working to simplify the top. So we can take the negative sign, and we can distribute it into all those terms. And that's going to give us, let's see, 2x cubed minus 2x plus 3x squared minus 3 minus, where did that parentheses come from? Let's get that out of there. 3x squared minus 3, then minus 2x cubed minus 6x squared minus 8x, and that is all over x squared minus 1 squared. All right, now it's time to identify common or like terms, and we have now it's time to identify our like terms. We have 2x cubed and negative 2x cubed, so those are going to cancel out. Then let's see, we have a 3x squared and a negative 6x squared, so that's going to combine to be negative 3x squared. Then we're going to have a negative 2x and a negative 8x, so that'll be negative 10x. And then finally, we're left with just a negative 3. And that is all over the quantity x squared minus 1 squared. Now, when we get to this stage in the game, we should try to factor the numerator. And we are able to factor the numerator to be negative 3x plus 1 times x plus 3. And that's all going to be over x squared minus 1 squared. Now, when this is in completely factored form, we can see that there are no common factors in the numerator or the denominator, so that means we are finished. And we can submit our answer in factored form, or since we weren't able to cancel anything out, we could also leave it in expanded form. Either of those are the correct answer, either of those would be accepted on the exam, and either one of those should be accepted in Newton. All right, our next example, we want to let k of t equal 4t minus 3 all over 5 minus 4t. And for this one, we not only want to find the derivative of function k, we want to find the derivative of function k when t is negative 3. So here is one of those odd notations that do come up every now and then. But in order to find the derivative at t equals negative 3, the first thing we have to do is actually, find the derivative. And now in this particular problem, we're going to take the training wheels off, meaning we're not going to do that scratch work on the side, and we're going to take the derivative as we actually use the quotient rule. So, first things first, we need to find the derivative of k. And the derivative of k is the derivative of the top, so the derivative of 4t minus 3, which is 4, and then times the bottom, which is 5 minus 4t, and subtract the top, which is just 4t minus 3, times the derivative of the bottom, which is negative 4. And that's all going to be over the bottom squared, 5 minus 4t squared. All right, so now we can continue to simplify, so we'll distribute, 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 distribute. Again, we're going to leave the denominator alone because it's already in factored form. So the numerator is going to be 20 minus 16t minus negative 16t plus 12, and that's all over 5 minus 4t quantity squared. All right, we can continue simplifying the numerator. We can take the negative and distribute it in, and that is going to give us 20 minus 16t plus 16t minus 12 all over the quantity 5 minus 4t squared. And then we can continue to simplify this down by combining like terms. I have a negative 16t and a positive 16t, meaning those are going to cancel out. And then we're just left with 20 minus 12, which is going to give us a numerator of 8, and that's going to be over the quantity 5 minus 4t squared. So now we found the general derivative for the function k. Now we just want to find the derivative when t is equal to negative 3. So we'll take dk dt when t equals negative 3, and we're just going to substitute negative 3 into our derivative. So that's going to give us 8 over the quantity 5 minus 4 times negative 3 squared. And then we can continue to simplify the denominator. And let's see, that's going to be 5. Negative 4 times negative 3 is 12 squared. That's going to give us 8 over 17 squared. And now we're just going to figure out what 17 squared is. And that's going to be 289. So that means our derivative of the function k at t equals 3 is going to be 17 all over 289. And then our final example is a word problem. And this example says the concentration of antibiotic in the bloodstream t hours after being injected is given by the function c of t is equal to 3t squared plus 2t all over t cubed plus 18, where c is measured in milligrams per liter of blood. Find the rate of change of c of t at t equals 6. Now, this particular word problem, or problems like this, do tend to give students some difficulties because it doesn't explicitly say what they want you to do in math language. So we need to do a little bit of interpretation here. And the key to this problem is rate of change. And let's remember that rate of change means slope, and slope or rate of change also mean derivative. So what are we actually trying to do? Well, we are trying to find the derivative c when t is equal to 6. So we are trying to find c prime of 6. So that's what this question is asking, and it's just filled with the other real-world applications to give you an idea of how the quotient rule can be applied. But first, let's find the derivative. So we're going to have c prime of t is equal to, we have to take the derivative of the top, which is going to be 6t plus 2, times the bottom, which is t cubed plus 18, minus the top, which is 3t squared plus 2t, times the derivative of the bottom, which is going to be 3t squared, and that is all over the denominator, t cubed plus 18 squared. Now, we could solve this problem like we have the others, where we could distribute everything out and simplify it down as much as we can, and then plug in the t. However, if you wanted to, we could actually plug in 6 for t right now. It's going to be a little bit messy when we write this all out, but it will actually save us some time because we won't have to simplify anymore. So that means we're going to have 6 times 6 plus 2 times 6 cubed plus 18 minus the quantity 3 times 6 squared plus 2 times 6 times 3 times 6 squared. And that is all over 6 cubed plus 18 squared. All right, so then we just need to simplify each of these. So let's see, the numerator, we're going to get 6 times 6 is 36 plus 2 is 38. Next, we have 6 cubed plus 18. That's going to be 234. Minus, and let's see if I can fit this in here. What's that going to be? 6 squared is 36 times 3 plus 12 gives us 120. And then 6 squared is 36. 36 times 3 is going to be 108. So, whew, just snuck that in there. It doesn't appear as though that's very readable, so let me write this underneath. So now let's just make this a little bit more readable. So what was that? 38 times 6 cubed plus 18 was 234 minus 3 times 6 squared plus 2 times 6 was 120 times 108. And then the denominator is going to be 234 squared. Alright, so we continue to simplify. 38 times 234 minus 120 times 108. That's going to give us negative 4,068 in the numerator, all over 234 squared, which is 54,756. And now that is the exact answer. However, Newton might ask you to round to the nearest decimal, and they will tell you the decimal. So let's just go ahead and let's do negative 468 divided by 54,756. And let's round that to 4 decimal places. So negative 0.743 would be the decimal approximation. And again, Newton will tell you how it wants you to round. Alright folks, that is using the quotient rule to find the derivative of a function in the form of f of x divided by g of x.